Hello and welcome to another V-Ray featured short demonstration. In this video, we'll look into the volumetric effects in V-Ray, such as the V-Ray environment fog and the V-Ray aerial perspective. In a second part, we will examine the V-Ray volume grid, which allows for loading and rendering volumetric cache files, such as OpenVDB, Field3D, and PhoenixFD Aura files. The purpose of a volumetric effect is to simulate the way light scatters from the particles in the atmosphere. The longer light travels in the atmosphere, the more it scatters. As a result, objects that are far away appear less visible compared to those that are nearby. Let's take a closer look at the V-Ray environment fog. It's a volume shader which can be applied to specific objects or globally to the whole scene. It scatters light from both direct light sources and indirect illumination. It is created and adjusted from the Environment and Effects window. By default, the effect is applied on the whole scene and can be limited by height from the fog height parameter. Note that if the camera is above the height limit, the volume boundary will be clearly visible. In this example, the camera's Z-coordinate is about 2 meters high. So let's raise the fog height to a bit more than that. Alternatively, the fog can be restricted to a volume defined by a geometry object from the gizmos list. The overall density of the fog is controlled by the fog distance parameter. Lower values make the fog thicker, and higher values make it more transparent. In addition, the density can be controlled by plugging a 3D map in the fog density map slot. By increasing the step size parameter, you can speed up the render at the expense of precision. The color of the fog can be set from the fog color swatch. Currently, the fog isn't scattering indirect illumination. By enabling the Scatter GI checkbox, the light coming from the environment, a V-Ray sky texture in this case, will illuminate the fog. And the scatter bounces controls how many bounces of indirect illumination should be scattered in the fog. Although this increases the realism, it requires more calculations and slows down the render. That is why a similar but less accurate effect can be achieved by plugging a bright blue color in the fog emission map slot. The fog can be optimized further by disabling its contribution on different shading aspects of V-Ray, such as background, reflections, refractions, shadows, and global illumination. While in this example, the V-Ray environment fog is set to simulate atmospheric fog, it can be used to create effects such as God rays, volume light, clouds, and other complex volumetric effects. With its many functions, it's a powerful tool, yet for simpler effects it may be somewhat time-consuming to set up. That is why as of version 3.3 of V-Ray for 3ds Max, there is a new fast-to-setup and render environment fog type of effect called aerial perspective. Let's have a look at it. Its purpose is to achieve the same effect of light scattering from the atmosphere, but with less parameters to tweak and faster rendering speed. It has only 4 parameters. Visibility range to control the density, atmosphere height to set the vertical limit for the effect, in-scattered light intensity, which is a multiplier for the emission of the fog, and the Affect Environment Rays checkbox that enables this effect to occlude the background and simultaneously scatter illumination from the environment. Let's load up a more complex scene so we can see the new aerial perspective effect in action. As a version 3.3 of V-Ray, there is a new sky model called Hosek that is used in this scene. When used in conjunction with the aerial perspective, we could achieve more natural results. In this short video tutorial, we have covered the volumetric effects in V-Ray together with their essential parameters for fine control such as density, height, emission, and color. I hope you have found this video useful and helpful. Make sure you check out more V-Ray featured videos. Thanks for watching.